Okay, welcome back. So in this next part, we're going to take a look at some functions that Pandas comes with that allow you to read and write data files in a variety of different formats. We can read and write data in comma separated value format. We can read and write HTML documents. We can read and write JSON files, which is yet another kind of structured data. So we're just gonna. This is messy and complicated. So I'm not gonna fantasize that you will remember this stuff in detail. But I just want to show you some examples of how these things work. All right. So back in lecture 4, we created for ourselves this data frame called F5. And let me recreate that for myself now. Okay, so I'm going to say import numpy as np, import pandas as pd, and I want to create for myself, come on pandas, there we go, and I want to create for myself a 3x3 matrix of random normally distributed values, except that I want to have the same sequence as everybody else. So I'm going to force the seed np.random.seed to be 1, and then I can say let's have A5 be an ND array, np.random.randn. Okay, so randn means that I want to draw values from a standard normal distribution, and in particular I want to get a 3x3 matrix of these things. I don't want these things to be displayed out to 7 decimal points, so I'm going to round them to just 3 places. And here's my my ND array, which is a 3x3 ND array of these values. Now to store that into a data frame, I can use my ND array as the data. So this thing is going to be called F5, and it's going to be a pandas data frame where A5 is the data, and then my index labels and my column labels are going to be these very clever names, R0, R1, R2. So index equal R0, R1, R2, and columns. I'm lazy, so I'm going to copy and paste and edit. Okay, so I want C's instead of R's. So C0, C1, C2. Yay, so I now have F5 as a data frame. And it has nice row labels, it has nice column labels, and it has interesting looking values inside of it. Good? Now, if I would like to save this data frame into a comma separated value file, I can simply use the toCSV method and specify boodles of arguments here. The only one that I'm going to specify at this moment is the file name. What do we call this? F5.csv, F5.csv, CSV. All right, I didn't get an error, so apparently that worked. Let me pull up my terminal and track down where that thing got written. And there it is. Okay, so there's my f5.csv file. And shazam, it is a comma-separated value file. So I've got the first row containing the column names, and the subsequent rows containing the row names and row values. And I can, suck this into Excel or whatever. Now, to read that thing back into Python, I could try using the read CSV method of the pandas module and see what I get. So I'm going to say f5 copy gets pd.read CSV f5.csv. All right, didn't get an error, so something must have happened. So let's take a look at what f5 copy looks like. Well, that's not. I expected this data frame to be the same as the one that I wrote out, but it's not. It seems to have these default labels 0, 1, 2, and it seems to think that these indexes 0, R0, R1, R2 are data of some kind. So I need to grovel around in the documentation some more and discover that one of the billions of keyword arguments for the read CSV function allows me to specify which column contains my index labels. Okay, so here is my actual file. Each line in this file has 4 fields, and the first field is the row labels. Notice that the first line actually doesn't have a value for the first field. So I will now say f5 copy equals pd.read CSV. Okay, now actually I should move this up. Let me move this window up. Because this is a really good illustration of how awful dealing with data is. Look at all that stuff. I've got sep, delimiter, header, index, use calls, squeeze, prefix. There's like 50 keyword arguments here that all have different particular meanings that you need to look up in the documentation to figure out what they all do. Fortunately for me, I can just say f5.csv, comma, and then index call equals 0. Okay. Yay, I got back the same data frame that I wrote out by only having to spend half an hour reading the documentation to figure out that I needed to say index call equals 0. Okay, so really powerful, really convenient once you have studied it for a while. Okay? Yes? It's the index of the column. Yeah. Yeah, if I had said, just for gags, let me say f5a gets pd.read CSV, f5.csv, index call equals, let's use the last column, 3. Okay, now I have these values, these random values as my column labels, as my row labels, with a column labeled 0 with R0, R1, R2 as values in the table. Okay, now if you have a comma-separated value file that simply doesn't have any row labels, then you're all set. Because in that case, if you just say read the CSV file, you will get these default integer labels of 0 and 1 for the two rows. Okay, so if you're okay having labels 0 and 1 for the rows, that's fine. And in fact, this kind of CSV file is a really common kind of thing for Excel to produce, where you've got the columns named, but the rows are just 0 through whatever. And if you save that as a CSV file, you don't have row labels in that data. So if you've got a table in Excel and you save it out as a CSV file, you can typically just read it right into a data frame in Pandas, and you'll get these default labels of 0, 1, and 2, and so on. Now, on the other hand, here I have an example file in which I do have row labels, but I don't have any column labels. So in order to read this thing in a meaningful way, I'm going to have to use my index col equals 0 to indicate that R0 and R1 are the row labels. I probably want to have named columns. And so I'm also going to add my names keyword argument. Now, I'm confident you don't remember this, but when we created the data frame using pd.dataframe, the keyword argument that we specified for the columns was columns equals and then a list of names. Here, no, we can't be consistent. We have to say names equals and a list of columns names. So more frustrating, random, inconsistent stuff to look up or remember or what have you. But this enables me to read in a columnless, a column headingless file and get it into a data frame that looks good. Yes?
I still cannot get the meaning of index column. So what's the meaning?
Okay, let me create this file really quickly. VIF7.csv. Actually, I'm going to make a copy of f5.csv called f7.csv and edit f7. And I'll just come back here, and I'm just going to delete the column labels. Okay, so I now have a comma-separated value file that has row labels but no column labels. I don't want R0, R1, and R2 to be treated as data. I want those to be treated as labels for the rows. So what index col does is to specify to the readCSV function which one of the columns in the input file should be treated as the index labels. And I want the first column, which is column 0. So that's going to cause R0, R1, R2 to be treated as labels. And then because I don't have any column names at all in this F7 file, and I don't want to have default names of 0, 1, 2, I'm going to also specify names for my columns. Okay, so let me save this file. Here's the file f7.csv, and then in my hey, wait a minute. Oh, f7 7 f7.csv, and then in here I can say f7. Hey, f7 gets pd.read CSV, f7.csv. The row labels are going to come from column 0. So index cols gets 0. And then the names of the columns are going to be C0, C1, C2. Oh. I just forgot my S. Not name, it should be names. Okay, moment of panic, but no, it was just a typo. Names. Not NAMA, names. There we go. Okay, so reading all of this documentation about read CSV is a pain. But with any luck, if you're dealing with comma-separated value files, you'll find that your comma-separated value files tend to all have the same format. And so you'll probably only have to learn 1 or 2 or 3 magic combinations of read CSV options, keyword arguments, and be able to read and write your stuff. Yes? I'm sorry?
What's the use of index numbers? What are they commonly used for? R0, R1, R2?
They're just names for the data. Yeah, okay, good question. So R0, R1, and R2 are kind of stupid names. More typical labels would be like if you had a bunch of information about customers, then you might use customer names as the labels, and the columns would be attributes of those customers. You know, like what's their customer number, what's their phone number, what's their address, what's their, you know, last year's sales, and all that kind of stuff. Or another example would be, let's suppose you're keeping track of financial transactions, then the labels might be dates and times, and the columns would be details about the transactions. Anything else? Other questions? Okay. Okay, now, we have used Beautiful Soup to scrape a website and get a table of information out of a website. It turns out that Pandas has a read table function that is aware of HTML structure, and so you can use read table to get a table out of a web page if the HTML is perfect. Okay, a lot of websites will display what appear to be pretty good tables, but it turns out if you look at the actual HTML source code for the page that it's got some flakiness to it. And in that case, Beautiful Soup is typically robust enough to be able to wade through those problems. Read table may just crash. But if the HTML is very cleanly structured, then you can get a table out of a web page by just using pd.readHTML. Wait a minute. Oh, this is a typo. It should be read HTML, not read table. So let's try this. Now I definitely am not going to type that in by hand. So here we have. I have copied that into an idle program file, so I can paste it into my shell. Okay, so I'm going to read HTML, And this is the yield curve stuff that we've looked at before. And takes a little while, but it is working. Yay! All right. So now, table list is a list of all of the tables that are contained within that HTML document. And as we've previously discovered, there are 8 tables in that web page. Only one of the tables actually contains data. The other tables are just text and instructions and whatnot. As additional arguments to read HTML, I can specify that I only want to get the tables where the attributes is tchart, and I want to have the header line be the first row, the sub-zero row in the table, and I want the index column to be the first column in the table. It might be worth looking at this web page again. All right, so let's pull this guy up. Treasury yield curve, daily treasury yield curve rates. Here's the table. And in the table, the first row, it provides me with the column labels. And the first column, that is the sub-zero row and the sub-zero column, provide me with the column labels and the row labels. The row labels in this case are dates. And the data is all of these interest rates in the middle of the table. Make sense? So let's see if that magic works. And I've already typed this in. Okay, so this is going to give me a list of data frames. And in fact, there's only one. Table that matches the attributes that I search for. So there's only one data frame in my list of data frames. So I can say rates df is rates df list sub-zero. And now I can just print rates df. Okay, and it says squeeze text 65 lines. All right, I'm willing to unsqueeze that. And there we are. It's a, neatly formatted looking table. Obviously, although it took me, it took reading some documentation and some experimenting, but if this is a table that I want to have access to on a routine basis, obviously calling one function to get this thing is a lot easier than using Beautiful Soup to kind of bash through the children and the contents of the children, and then having to splice everything together into a list of lists. Good. And I mean, this thing is a data frame, so I can say rates df sub let's see, .loc sub 09 24 19 comma 3 month. And okay, so there is the 3-month interest rate on September 24th of 2019. Another common format, in addition to HTML tables, comma separated value files. Another common format that web data is often provided in is JSON or JSON, which is the JavaScript object notation. And it looks a little bit Pythonish. It is very well and very cleanly defined and described on the JSON.org website. Let's take a look at our data frame F5 again. And if I say F5.2CSV, that saves the thing in CSV form. But if I say to JSON, and let's call this F5.JSON. Some people pronounce it JSON, some people pronounce it JSON. I can't, it's not a person. I can't call it JSON. All right. And here is my f5.json file. Okay. And basically what we have here is an object containing 3 sub-objects. One sub-object is a column referring to 3 rows. Another sub-object is another column referring to 3 rows. And then we have a third column referring to 3 rows. Except that the notation is different, you can see that it contains the same information as the comma-separated value file does. If you go to various websites that are intended to provide data in a convenient format, you'll often find like a JSON button or a JSON access point where you will be able to just download JSON format stuff. And from within Python using pandas, you can easily convert that stuff into a data frame. And here we're going to take a look at an example. Now, the very first time I taught this course, I taught it for a class that was in Adelaide, Australia. Where we have an outpost. Carnegie Mellon has well, I think it's Heinz College specifically that has a school set up there, and Australia has some really nicely formatted data available. So if I go to data.gov.au, I will find Australia's public data. It's so nice. I don't think the US has anything that's nice. Let's see. So I want to search for, I want to search for, oh, look at this. I was going to search for Wyndham Smart Bin. I must have searched for that before. Actually, I'm going to search for JSON format. And what I get are all of the data sets that support the JSON format. In here is Wyndham City Council stuff. I don't know where Wyndham is, but what the heck. And they have their own, okay, there's 46 data sets in there about all the stuff to do with the town of Wyndham. And most of these have, well, all of these, because I searched for JSON, have JSON format stuff available. Now, Wyndham, I mean, this is just cool. Wyndham Maybe everywhere in the world except the US does this. But they have trash bins that are self-aware, that know how full they are. So I'm going to go to look at the Wyndham Smart Bin data. Oh. Can't find any data sets. No, this is my example. Wyndham Smart Bin. Oh. Yeah, I knew it was there. Wyndham City Smart Bins. So all of their trash bins around town are networked so that they can tell how full they all are at any moment in time. And I can obtain this information in JSON format. And there it is. Look at that. So this tells me the current status of all of the smart bins that exist in the city of Wyndham. Oh, look at this. Capacity high. Oh, so that one needs to be emptied. Let's see. All right. Well, anyway, I have this stuff more neatly formatted in my notes, so that we can see it without having our eyes crossed. All right. So here is the beginning of it. This is a JSON structure, and each value in the JSON document has a label and a value associated with it. And for a particular smart bin's fill level, we get told the precise latitude and longitude of the bin. We get told what the threshold is for fullness of the bin. We get told the current fill level of the bin, and we also get told a status. Now here, the fill threshold of this bin is 6, whatever 6 is, and it's currently empty. So it's not ready to be picked up. But elsewhere, I'm going to find a bin that has a fill threshold of 8, that's actually at 8, and the status is fullness. So that means that for this smart bin, I need to send a truck to collect the stuff. Okay, so all right, so here is the URL of that data, and I can say, let's create a smart bin data frame by using pd.readJSON. So let's see, smart bin data frame gets pd.readJSON, and then the URL, close the quote. Oh, look at that. I now have on my computer the status of the smart bins in Wyndham, Australia. How cool is that? And there are 32 smart bins in Wyndham, Australia. I can find out the shape. So there are 32 bins, and there are 3 pieces of information about each bin. I can find out about the first bin, all right, sbdf.loc sub 0, that's the first bin. And the data is pretty long, so the 3 dots here indicate that there's more data that I'm not seeing. I can ask to see the features of this bin. sbdf.loc0 sub. Okay, there are three, for each bin there are three pieces of information. There is a name, there is a type, and there is a features. So I'm going to look for the features. And there are the features. Now within this, I have properties. Okay, so within the features, I have type, I have geometry, I have properties. So this is a sort of a hierarchically organized data frame. It's not a simple row and column data frame. It's a data frame that has a hierarchy of sub data frames in it. And so now I'm going to ask for sbdf.loc0 sub features sub properties. Cool. There are the properties of this particular smart bin. And the status is in service. Okay, so apparently this particular bin is still functional. It's not full. Are you all impressed? Okay, I didn't expect that you would be impressed, but I did just want to show that with reading some documentation and experimentation and practice, you can suck down information from all kinds of places on the web and parse it up and analyze it in a fairly straightforward way. You can pull down HTML stuff, you can pull down JSON stuff, you can pull down XML stuff, and store this stuff in data frames and pick it apart. Well, okay, so this is a publicly accessible government data set. And so the stuff is, the stuff is free, the stuff is there, you can just get it. Commercial entities like Amazon, Zillow, Walmart, other places, often do have like throttles or other kinds of protections so that you might be cut off if you try to do too much automated downloading. One thing you can do if you've encountered that situation, usually once they've identified your system, you're stuck. You're not going to be able to download stuff from a website that has cut you off anymore. So find a partner who hasn't done it yet, and in your scraping code you can add a delay. Sometimes that works, so that you download a little data and then you twiddle your thumbs for a little while and then you download a little more data, and you can sometimes trick them that way. It's an arms race, because in fact I just got an email today from somebody who was saying they were using maybe it was Zillow, and that Zillow had thrown up a CAPTCHA thing to detect whether it was an actual person or a robot that was downloading. Well, but there's robots that know how to defeat CAPTCHA. So it's a constant battle to see how you can get around these blocks that get put in your way. Um, okay, well, I didn't think we were going to have time to get into string handling. I could spend 20 minutes doing this, but let's just hold off on it until next week. You don't need to know this stuff for your homework, or it's useful information, but it's mere information. You don't really need to know this stuff desperately for now. Shall we call it a night? Any questions? Okay, you've been so amazed by smart bins. All right, so we'll call it a night and pick up from here next week.